Oh, this is what I need to do. Oh, hi everybody. Hopefully you can hear me. Yeah, I think you can hear me. This is great. This is great. Welcome, welcome, welcome. How if I do this? Yeah, I should move this over just a tiny bit. There we go. Sorry about the green screen thing. I realized after I'd started that I hadn't set my green screen up, and I was like, oh shoot. It's December 21st, so happy winter solstice. Now you're probably wondering, some of you, what does that mean? We'll get into that in a little bit. The big news of today has to do with these guys, with these folks here, which is Jupiter and Saturn. We also have, I think, Venus and the moon down here. We're going to talk about that, which is really exciting. But this Jupiter and Saturn are in what we're calling the Great Conjunction of 2020. And tonight is the maximum conjunction. And if you are watching tonight, hopefully you can go out and see it. But if you're watching in the next couple of days, it'll still be something pretty cool to see. The conjunction is very close to maximum tonight, but is maximum tonight. But yesterday, tomorrow should be pretty close, and they'll just keep moving by. So we'll talk about that in a little bit as well. I haven't been streaming for a while because I broke my shoulder. Fell off a bike a couple weeks ago, like 3 weeks ago, and broke my shoulder and probably a rib or two down here. I'm doing fine, but if I seem to be like resting my left arm a lot through this, that's why. It's because it really hurt. So what we're going to do today is we're going to start with stellarium. Here we've got stellarium here. We're going to do what we normally do, which is kind of look at what the night sky is going to look like. This is what it looks like right now, where I live. So we've got the sun. It's starting to set. It's getting close to setting. Over here we have the moon. And so if we let the sun set, we'll see the cool thing that we want to start off with. So as the sun sets, and so for me it's setting 6:30 here, or 5:30, almost 6 o'clock. Here we go, right after sunset. Now, for some of you, you're probably living in a place where it's really cloudy, in which case you're not going to be able to see this. So I'm very sorry. Hopefully in the next couple days it gets a little bit less cloudy, but if it's cloudy tonight, there are ways on that you can find this live and watch this. But you can also watch this here, and we're running it. It won't be exactly what it looks like through a telescope. It'll be a simulation, but it'll be a pretty close simulation. But this is the night sky right after sunset here in December. And right now you'll have this planet here. Remember, planets wander around, as we've discussed in previous episodes, and so they're not always in the same place. So if you're watching this in 2021 and 2022, this is not going to be, the planets are not going to be conjoined like this. That's why this is kind of a really cool thing right now. The last time this happened like this, they were this close, it's like 400 years ago, and it's been 800 years since it happened during the night, I think is what I was reading. It's been it's a pretty exciting thing, right? It was where was the thing that it said? Yeah, it's 400 years since they passed each other in the sky, nearly 800 years since they occurred at night, as it will for 2020, which is very, very exciting. And what does it mean for planets to have a conjunction? Well, over the last couple months, I've been watching as Jupiter and Saturn have been kind of moving through the sky. Planet means wander, and the planets are in fact kind of wandering as they move around the orbit. In their orbit, they move around the sun. And we're also moving as well, which causes the planets to have interesting motions. So if you were to go outside at night, and then go outside the next night, go outside the next night, go outside the next night, and look for the planets and look where their positions are, you'd notice they change with respect to the background stars. And so that's what they mean by wandering. And it's because they're very slowly moving with respect to the background stars as they orbit around the sun. And we'll show that when we go back to Space Engine a little bit. But for right now, these objects look like they're just one object here. And that's pretty exciting for people, especially for people who've got telescopes where they can see both of the objects through the telescope. And we'll simulate that in a little bit. But if you've got a pair of binoculars, this is a really great time to go outside right after sunset and look towards the southwest. It's pretty straightforward to find the objects. You look for where the sun is set, look a little bit to the left and look for the brightest thing right there, right? It's not like you're trying to find some sort of faint little object here. You're trying to find an incredibly, incredibly bright object. And so and it's a pair of objects, so it looks even brighter, okay? The other ways in which you could find it, I suppose, are that right now, if you look over where the sun is, you can see summer triangle that we've talked about in the past. And the summer triangle is like an arrow right now. You can see there's an arrow just going beep, beep right here. Okay, so hopefully you should see this. If there's a tree in the way, get away from the tree. If there's a building in the way, go on the other side of the building. You know, you may want to drive out someplace where it's pretty clear and you can see the horizon. You don't have a lot of time to see it. You know, so if I let time go on a little bit farther, you can see that for me here with this field, it sets at about, you know, 7:30. So you got about an hour. Right, but really make sure you go and take a look right after sunset, right? Hopefully it's not too cold. Get bundled up, go outside. It's worth seeing. Bring binoculars, bring a telescope or whatever. If it's cloudy where you're at, which is the case for a lot of people on the East Coast right now, which bummer, because it's kind of like a once in a lifetime type of thing. You may want to like look online, as I was saying earlier. But here's what we've got. What does it mean to have these two planets conjoined? Well, they look like one object, and if we go back in time, that's not what I want to do. If we go back in time, we can see exactly what's happened, right? So nope, I keep clicking on the wrong thing, not the date. There. Watch as we go back in time to the same. So here it is, 10 days ago, 9, 11, 12, 13, 14. Here it is at the beginning of the month. These two objects here are Jupiter and Saturn. This is the same time of night, 6:05. But watch, 6:05, as I'm going in, they're slowly moving together. Right? With respect to the background stars, they seem to be getting closer and closer and closer and closer. And so once you get to the 21st, tonight, they're maximum closeness. And after this, they go past each other and you can see that they continue, So you see how they're moving? Right? Pretty cool. Pretty dang cool. And so you might think, are they right on top of each other? Well, this is what we can do here, is we can zoom in. And they look pretty close together, but look, as we get closer, they're not, right? They're not right exactly on top of each other. And in fact, they're separated by quite a bit in the sky. So if you're thinking this is some sort of magical thing where they're perfectly aligned, they're not perfectly aligned. Hey, Psycho Penguin. They're not perfectly aligned. Now, they're incredibly close. This is, very, very close. But they're not like right on top of each other. So don't expect some sort of magical thing to unlock. It's pretty remarkable from the Earth here, but it's not like something where, this means doomsday. So you've got Saturn over here on the right, Jupiter over here on the left. If you're looking through a telescope, it'll be flipped and inverted because of the way the optics works. We've also got some of these Galilean moons of Jupiter. So some of these bright moons. You can see the 4 brightest moons of Jupiter right here. And then you've got some of the moons of Saturn around here as well. The reason that it looks like it's moving is because the Earth is still rotating in this program and we're looking really close. So you imagine if you've got a telescope, you're looking this close at them, you're going to have to continue moving the telescope. We call that tracking the planets as they move around. Pretty cool. From the Earth, though, it's going to look like this. It's going to look like one object. If you've got really good vision, you might be able to resolve that they're two, but it's going to be pretty incredible. And so this is why I want you to go out and look at it right now. Okay. And so before I get back to the rest of the constellations, let's think about that a little bit more. And to do that, let's go to Space Engine. So I'm going to turn Solarium off, and we're now here in Space Engine. And we're floating here above the Earth. Whoa, I've got the fisheye on. Pretty crazy. We're floating here above the Earth. We've got the sun here, and there's our two objects right there. If I click on them and center them. We could also turn on our telescope and zoom in. And similarly, you've got Jupiter and you've got Saturn, right? And Jupiter, and these are the moons we were talking about, Saturn and its moons. We could zoom in a little bit more, and you can really get a good, nice look at Jupiter there. Pretty cool. But you might be thinking, well, does that mean that they're like going to touch each other? How close are they? Well, here's the cool thing. In Space Engine, we can fly there. So let's start flying towards Jupiter right now. So I'm going to turn on some of my interface here so that we can really see as we get closer. So we're flying towards Jupiter right now. It's a slow process. We're 5 AU away, 4 AU away. We're getting faster. I want to slow down in a second. 3. I really need to make sure I don't accidentally overshoot it. 2. We're going 169 times faster than the speed of light. 8, 7, 6. All right, here we go. Okay, so here's Jupiter. We're getting closer to Jupiter. Exactly as we kind of look like, but now you can see that the stars aren't moving because we're just flying towards Jupiter, and you can see these moons. And you're saying, well, where's Saturn? Well, oops. I'm going too far past Jupiter. going to Jupiter. There's Jupiter. If I do this, you can see there's Saturn up there. Whoa, 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 whoa. Man, I forget that if you don't do this right, you just screw yourself over. And there's Saturn. And now if I kind of rotate around, you can see that, gosh, I need to stop pressing that button. Here's Jupiter. Right here. Mercury, Venus, Earth, Mars, asteroid belt, Jupiter. Wait. Jupiter's here and Saturn's here. So this is the distance between Jupiter and Saturn right here. So you can see Saturn right here. Man, if I could ease the speed with which this is a lot better, then I'd be a way better jockey for this dang program. It is, in fact, very nice usage of the word. In fact, it is a syzygy, a conjunction, but generally a syzygy is with the moon and the sun in the sky, but it is just a conjunction, right? So, if we fly out right now, you can see Saturn, Jupiter, Mercury, Venus, Earth, right there. There's the Earth Moon barycenter. And from our point of view, Jupiter and Saturn look like they're in one line, but they're not anywhere close to each other in space, right? One's way over here and one's way over here because they tend to not get close to each other because of their orbits, right? But from the point of view of the Earth right now, you can see that they line up pretty well. So here's the Earth. We've got the Earth right here. Jupiter and Saturn, our syzygy, our straight line-ish that goes between all three of these planets. So if you're living on the Earth right now, which we are, you can look out and see these two planets looking like, but over time, so if we fly up a little bit outside of the solar system, so really what you want to be looking at is Earth here, Jupiter and Saturn, as I make time go on faster, they're all starting to move. And look, notice Jupiter's moving faster than Saturn. So it's actually going to be moving. And also Earth is really rotating around, right? So if you stop right here, if we just make time stop and float back down to the Earth, you can see that, so if I float back down, you can see that now, from the point of view of the Earth, so this right now is, 2021 April, Jupiter's way over here and Saturn is way over here. So think of them like on, these tracks. And they've been moving around, and this one's moving a little bit faster, and now it's caught up, and now they're just in line with us, and then it's going to keep passing on, right? So as this has gone around, these ones have gone around with a speed that means that inner ones are going a little faster, and so it has actually overtaken Saturn farther out. But for tonight, they're lined up pretty perfectly. And so if we go back to tonight, boom, here you can see, or actually right now, you can see the lineup. Extraordinary lineup right there. Boom. Earth, Jupiter, Saturn, right? So if I click on this and we go to the Earth, they'll line up just perfectly right there. If we turn off our orbits, you can see them and we can fly towards them again. And they stay as like one kind of beautiful point, even though they're a tiny bit away from each other as they go around the sun, which is pretty incredible, right? So just as a refresher, in case you are unaware, want to learn a little bit about Jupiter and Saturn. Jupiter is the biggest planet in the solar system. If you took all the rest of the planets and added them up, all the rest of them, Saturn, Uranus, Neptune, Mercury, Venus, Earth, Mars, added them up, you'd be less than half of the mass of Jupiter. It's a real big planet. You could fit about 1,000 Earths inside of this. So here, by the way, is Saturn. You can see it right there. Still incredibly far away. So you can see all of this striping and banding on the surface is mixtures of different gases in the atmospheres that are at different densities, and they're kind of mixing around. The way I like to think about it is swirling coffee, cream into coffee. You get these similar kind of swirls and whirls. This is the famous Great Red Spot, which is a giant dust storm that's been millions of years swirling on the surface. The gas surface, it's most entirely hydrogen and helium gas. You could fit about 2 or 3 Earths across it, which is pretty impressive. You've got one of the 70 moons of Jupiter. Jupiter's just got so many moons. You can see just 2 of them as we go around. You can just see all these dwarf moons. Because Jupiter is massive enough that it just really picks up on moons over time. So here's Europa. If we fly to Europa, you can see that from Europa, Jupiter looks like this right now. Beautiful crescent Jupiter. If we get closer, we can go over to this one. Let's go to this moon right here. Let's go over to Ganymede, because Ganymede's got a real nice view. Not a crescent, but a full, right? Which is pretty impressive. If you were standing on Ganymede right now, so if we go to Ganymede and we like land on Ganymede, and look out in the nighttime sky, this is what you get. So imagine living on the moon, you get the Earth, it's pretty far away, but from Ganymede, you get a pretty nice Jupiter because it's a really beautiful giant planet. And so if you look for Saturn, you can see that from a telescope on the surface of Ganymede right now, you can see Saturn down here. So this is from Ganymede, orbiting the planet, and it's still, you need a telescope to see Saturn through the telescope. So it's pretty far away. Right? They're not like right on top of each other. They just happen to be lined up perfectly for us, which is really nice. Nice. Right? So let's take back off from the surface of Ganymede. We'll pass Jupiter and continue moving out towards Saturn. It's taking a while. I have to slow down or else I'll overtake it too quickly. I'll just press go. That way I can do it ease in and ease out. And what's cool is we can do something pretty fun, which is we can look at the conjunction in the sky right now between Jupiter and Earth on the surface or orbiting Saturn. So here's Saturn. Saturn is very similar in its composition to Jupiter, except it's smaller. Still has the striations and the storms. It also has this beautiful, crazy hexagon on the surface, or on the poles right here, which is what happens near the poles when you have this type of gas. We've actually simulated it in the lab. It's got these gorgeous rings, which are most likely, the result of collisions between moons early in the history of Saturn. And it's got its own large numbers of moons, including the largest, which is Titan. My brother just bought a dog, and his wife bought a dog named Rhea. Rhea is another one of the moons of Saturn. So if we stay over here and look towards the sun, so the sun, I can't believe I'm missing the sun. It should be, there's the sun. And we say, you know what I want to look towards? I want to look for Jupiter. And then we look at Jupiter through our telescope. There's Jupiter. And Earth, right there. Jupiter's got its back to us right now, so you can't really see it. But this is Jupiter, and then here's Earth. So there's a conjunction between Jupiter and Earth. Now the problem is that Earth is on one side of the sun, and it's being lit up. So if I focus on Earth right now, we really zoom in, you can see Earth's being lit up, right? So we're looking back at Earth right now. Why isn't Jupiter lit up? Why can't we see Jupiter? Why was I having a hard time finding Jupiter? What's going on here? Well, let's increase our exposure compensation here so we can really see. Well, it's because Jupiter's just a crescent, because think about it. Right now, Jupiter and Saturn are lined up, and the Earth's on the other side of the sun from both of them. So the sun is shining on one side of Jupiter and shining on one side of Saturn, and it's shining on the other, it's shining on one side of Earth. We can see that side of Earth from Saturn, but we're seeing the back side that's not lit up of Jupiter right now. So that's why we're seeing just this little crescent. I've turned on the exposure compensation, but generally it's really dark, okay? And so that's why it would not be as exciting if you were on Saturn to see this conjunction, because right now the conjunction is pretty cool for us because we are existing closer to the sun, and therefore we're right now on one side, and it's out there on the other. You know, if we were over on the other side of the sun, we would, you know, at nighttime, like at midnight, we'd see this conjunction, which would be pretty cool. But right now, we're just on this side of the sun. So you've got to wait until just after sunset. If we were more on the other side, then the sun would be in the sky at this time, and it would happen during the day, which is a bummer. But this is, you know, what the conjunction would look like from Jupiter and from the planet Saturn, right? So if we turn back around, you can see, you know, we wouldn't want to stand on Saturn right now because there's nothing to stand on, but we can stand on, say, one of these little moons here. So this right here is Pandora, which is the name of the planet from Avatar. Whoop. And it is really dark right now because Space Engine sometimes does a bad job of actually rendering things like this, so we won't actually land there. We can land on this one. And Celadus. Celadus better be lit up. It shouldn't be the same way. Yeah. We'll land here. Space Engine has a hard time sometimes rendering things, but we'll land right on Celadus. Ooh, look out again. So this is from the planet Enceladus. Oops. Click go. So now we're actually going back towards Jupiter. This is the back side, and if I rotate around, you can see once again the front side with Saturn well off in the distance. Pretty cool. So you see, this is what we're seeing because that's where the sun is, right? So hopefully you're understanding this kind of three-dimensional structure of our solar system, that, you know, we've got these planets moving around. So it's not it's a special thing for us in that they line up. Pretty cool. But it's not like they're touching each other or like, you know, they're pretty far away and they just happen in the sky to be pretty close, which is pretty neat. So if we return back home, fly all the way back to the Earth over here, and look out again, here's the sun, and we look back at this lineup. Let's land on the sun, or land on the Earth. Let's land on the Earth here. Here it is. Here's where we are. I'm gonna land, you know, in the middle of the desert here. Hopefully we, you know, so now we're in the middle of the desert, and we look back up at the sun and everything. Pretty cool. We're on some sort of hill here, which is very nice. We can make time go on again. Wait for the sun to set. And when the sun is set, we can do what we did with, boom. So the sun is just set, and we can do what we did. We center these and really zoom in. And now, let's imagine you've got a telescope and you want to know which objects you're going to see tonight. Let's just talk about what you're seeing here. So I'm going to turn back my interface on. This farthest object is Callisto. Right now we've got Io. You can see it on top, but it's actually really hard. But there's a moon actually in front of us. You can see it here. And it's going to be a little tough to click on it because it's in the way. But over on this side, you have Europa. And then way, way, way out over here, you have a white subgiant. So it must not be. So this must be Ganymede, right? Callisto, Europa, Io, Europa, and this must be Ganymede that is here. And if I search for Ganymede, we can make sure. Yep, it's right in front. So you're going to see three moons and one of them right on top, but this is at this time of night, right? And then if we zoom back out and look over here, click on Saturn, the moons you're going to see on Saturn, around Saturn right now, Titan, there's Titan way out there. On the other side, Rhea, so these are my brother's two dogs, Dione, and Tethys, and the way out here is Enceladus, right, which we were just talking about. And there's some other ones that'd be a little harder to see, Mimas and stuff. Mimas is kind of neat because Mimas looks like the Death Star. But again, most likely, it might look like something like, you know, this through your binoculars. Like you should, you know, with some, like my kind of crummy binoculars, that's what it's probably going to look like. Maybe even like this, you might just barely. It takes pretty good magnification to see that Saturn has rings. You can just barely see it here, right? Hopefully it's, you know, you've got a good enough resolution in this to see that. But if you've got a nice telescope, you can actually see both of these in the eyepiece, depending on the size of your eyepiece right now. And these are the names of the moons and how they're going to be oriented. So you can see really that these are just like this beautiful line. These are the 4 Galilean moons as discovered in 1610. The last time there was this type of a syzygy to use the word that Psycho Penguin used just now, was 1623. So let's look at 1623. Why not? Let's go back to July 4th, 1623. So I'm going to turn on Stellarium again. And we're here with Stellarium. We're going to go back in time to 1623. 1623. And we're going to go to July 4th, 7/4. So July of 1623. The telescope had just recently started to be used for astronomy purposes, which is pretty incredible, by Galileo and some other people who were starting to look up using this object that was invented mostly as an instrument of war to look out at ships or battlefields. But when Galileo and other astronomers heard about this, they were like, oh man, I should look upward at the stars. So I'm going to put ourselves, actually, we're going to go not to, I need to stop clicking on the wrong place. Not Tucson where I live, but we're going to look at, I don't know, let's look at Florence, Italy. Boom. Aha! So here we are, Florence, Italy. Beautiful, beautiful Florence, Italy, right on 1623, July 4th. And we're going to go right back to after the sun has set in the west. And so here's the moon, Regulus, Spica. And so what I want to do, I think I actually should go back. I want to find where Jupiter is right now. I was just doing this earlier. There we are. If I look at Jupiter, we can see up here is Mercury and Saturn. All these planets, if I make time go on just a little bit faster, oh man, I should turn off this stupid tree. We're going to do sky and viewing options. I'm going to change my landscape to this Garking landscape, which hopefully, I clicked star surveys, which means that this program takes a couple minutes to deal with that. Did I just, no, I did not. Good. Is this also behind a tree? Let's turn on 0 horizon. No horizon there. All right. So as they go on, you can see that, oops. Near the horizon here is Jupiter, Mercury, Venus, Saturn, right? So Jupiter and Saturn, but also Venus and Mercury. Right after sunset, if you're looking right on the horizon on July 4th, you can see this incredible conjunction, similar to what we see tonight, except with 2 extra planets. That's even cooler. That's a pretty cool syzygy. The problem is this is pretty low to the horizon. You'd have to be really lucky to go out right after sunset and be able to see right against the horizon. So maybe if you're on a boat on the ocean, but generally it's thought that most people did not see this in 1623, which is kind of a bummer. If we go on time-wise, we can see how they moved also, right? So this is 623. So this is as we're getting into Jupiter, or getting into July. So if I look at Jupiter and Saturn here, you can see that they're getting closer, but they get close enough and it's not possible. Can't see it. Happens below the horizon here. I've turned the atmosphere off, by the way. If you turn the atmosphere back on, it's just still after the evening. All right. So it's most likely that this was not visible. But this is the last time this happened. It was right after the invention of the telescope. This pretty cool thing. So tonight is the first time in modern history where we're getting this, and you're going to get lots of very, very cool images. Okay? So let's go back to now. And let's go back to where I live here. Turn off my constellations. Let's turn off my this. And I should turn off the there we go. Let's go back to Tucson. The thing where if you click enter, it goes away. And here's what we've got. I'm going to turn back on also my landscape. I like this one. Turn the atmosphere back on. So make time go on till we got just after sunset. So that's the conjunction. Totally go out, totally look at it. Okay? Won't be visible right between sunset and like an hour after sunset. Really go out and see it. But let's say you go out after that and you're like, you know what? It's a really nice night. What else can we see? Well, let's do what we always do in this. Let's turn on our sky map. Here's our sky map. Our sky map that I use, it's from skymaps.com, and you can see it's December 2020. It's early December, it's 8 p.m., and late December at 7 p.m. So this is right after, essentially, because we're mid to late December right now. I guess we're late December. But this is essentially what it'll look like right after you look at that and the Saturn and Jupiter have gone down, and you're like, we want to make the most of our stargazing. What else can we see? Well, remember to use a star map. You print this out. You hold it so that the word south or east north or east or south is on the bottom towards the direction you're looking. So right now, if I were holding it like this in my hand, like I can put my hand out here. If I were holding this in my hand, I would want to be looking south because south is what I can read there. So if we go back to Stellarium, we've got south. And remember, the way we find south, I say this every time, is we look for the sun has set. That's westish. And we turn about 90 degrees to the left. Pretty straightforward. So we're looking south right now, and you can see if we go back to our star map, so let's shrink this down, you'd hold it in your hand looking with this like this. And so hopefully if you look out towards the south, you can see some of the stars that we see here, right? So let's say, can we identify this star that's really bright right here in the south, right? There's another star up here. If we kind of zoom out a little bit to get a better picture of what we're seeing, there's another couple stars. There's like a triangle of stars that we're going to want to see, right? So, oops, I'm moving myself. There's like a triangle of stars that are pretty bright. I think I'm in the way of one of them down here. Am I? No, I'm not. Oh, yeah. There's triangle of stars. So let's look at the star map. Let's make it real big. So it looks like maybe we've got Difta and Fomalhaut and then a star here in Phoenix that we might be able to see, right? So let's click on one. What do we got here? This is Difta, and this is Fomalhaut. And this star, which is in Phoenix, is called Anka. It's Alpha Phi, right? Look at that. All it took, right? We come out at the right time. We look for the brightest objects in the star map. So hopefully you can see if I go back to here and click on, you can see Difta and Fomalhaut, and then this star here, which we just called as, what do we call that? I've lost it. Anka, which isn't even named on here, the brightest star in Phoenix, right? In the south. And these are not really bright stars. Fomalhaut is a word that means, I think it means like the lonely one or the solitary one. There's one of them that does. But Fomalhaut is like one of the brightest ones in this large area. Difta as well. Difta's in Cetus. And what's cool is the other way, now we've got this, we can take these two and kind of like, what do we got up near them? Well, we've got the moon, pretty straightforward. And if we go up a little bit, we've got another object up here, which is, pretty close to straight above us. And if we look back at our star map, actually, you couldn't see any of that. Here. Shrink the star map down so you can see it. You can see the moon, and you can see another object above it, right? So the moon and then this other object right here. So again, if I went back from where we were just looking, we were looking south, we found Fomalhaut and Difta, and above it was the moon, and above that to the left was this object here that's fairly red, fairly bright. We've talked about it in the past. If we go back to our star map again, you can see this dashed line is the line where planets and the moon are going to live. It's the ecliptic. But above Mars here, or above where we just talked about Difta and Fomalhaut, is Mars. And so that object must be Mars. This is how we're using our star map. We're just saying, this is what it should look like. Here's how we hold it. If we wanted to look towards the west, we'd have to rotate this 90 degrees. So let's do that. See if we can do that with grace. It's really not a thing I can do super gracefully. There we go. So now we're looking at this to the west. And so let's look to the west in our stellarium. So we kind of zoom back out. We look towards the west, which is, again, where the sun has set. And we've got a tree in the way, but we've got a couple bright objects here and then another bright object over here. Pretty interesting. Let's see what they are. Let's see what they might be. Sky map again. And it looks like maybe what we're seeing towards the west is Altair. Are we seeing the summer triangle? Oh, in fact, we are. That's what we're seeing right here. We're seeing Altair down here. And we're seeing this must be Vega up here, and then this must be Deneb. Right? We know the summer triangle. We've talked about that many times. And you can see Altair to Vega to Deneb right here. Altair to Vega to Deneb. And so, sure enough, Altair, Vega, whoops. There's apparently a satellite that's in that part of the sky, to Vega, to Deneb. Actually, to Satyr, this is Deneb up here. Right? The summer triangle. Part of Cygnus the swan, and down here is Aquila the eagle, and Vega's in Lyra the lyre. Krinkelschmidt, welcome, welcome. Oh man, I turned my sky map. Let's go back to what I was saying. Altair's down here. Deneb's up here. And Vega, which is next to some satellite that's artificial satellite that right next to Vega. So if you happen to see this, this is this annoying artificial satellite that's orbiting the Earth that's preventing me from clicking on Vega, the brightest star that I think is up. That's not a planet right now. And so that's west to northwest. Exactly, if you look back on our sky map, bink, is west to northwest. The sky map is perfect for this time of year. This is why you use a star map. Pretty cool. If we rotate again 90 degrees, let's do it. Ba-dink. Now we're going to be looking north. So let's turn off the sky map and look north in our program. So we're looking west. We know we've got this. Let's go 90 degrees to the right. We're looking north now. What do we got? Well, we've got an object up here. I shouldn't put an object up here. We got an object down here that's bright and kind of another, it's kind of like this triangle of objects. This one has an object next to it, some star next to it. What do we got? What could it be? Sky map back on. Bink. Well, we've got something up here and maybe something down here and then something going down here. Maybe this is our triangle right here. And it turns out, in fact, that would make the top one Polaris. This is, in fact, Polaris, and this is Ursa Minor that's stretching down here. So your Ursa Minor stretches down like this, and this is a star in Ursa Major. This is Doobie. Ursa Major, or the Big Dipper, you can't even see it. It's behind this dang building, right? So you'd have to wait till later in the night before it rises. But Ursa Minor, you can see it pretty well. Now, if you're really far to the north, this star will appear higher up, right? If you go up even farther north. Here, let's simulate that. Let's go up here. Now we're in Canada. First off, there's Polaris and the same stars. And look, you can see all of the Big Dipper. It's because as we're going up farther north, we're seeing stars that were below the horizon start to rise up because the Earth's not blocking their way. Pretty cool. If we were to go to the North Pole, which I wonder if we can actually do that. Let's go to the North Pole together. No, why do I keep clicking the one wrong thing? I'm just not thinking. North Pole? No. I wonder if I just click way up here. Let's just go as far north as we can. Well, what's right up straight up above us? The North Star, right there. Here we are at the North Pole-ish, close-ish. We're 86 degrees instead of 90 degrees. And look, the Big Dipper is like fully visible, right? The horizon, you go all the way up. We really found a way to go see it. And look, right up straight above us is the North Pole and the North Star. That's why we call it the North Star, because the North Pole points towards it. Oh, we had a shooting star. Everyone make a wish. So if you go back to Tucson, man, it's not going to let me. Click. There we go. You can see that from the point of view of Tucson, you can see the Little Dipper, but you can't see the Big Dipper at all. The Earth is blocking the way. Got to go farther north, right? So that we found that, and then let's turn back on our sky map. Are there anything else that we can see while we're up here? Well, let's see if we can trace out Draco. So if we look between the two, there should be some stars that trace out a shape of Draco. Let's see if we can trace out Draco. It's a fun one. Okay, so we go between these two, and it should be here and curving up, and then there's the head. Can you all see that right there? I can see it. Trace it up and around. There's the head of Draco the dragon. The body goes around here. These two stars are called the guardians of the pole because they're protecting the pole star, the Polaris, from this dragon. If I turn on my constellation lines, you can see I was totally right. I'm very good at this. I guess that's why I have a degree. But let's finish off by looking towards the east. Look towards the east. Oh, man, and here's where it just gets great. Turning on our sky map, rotating the sky map. Whoops. One more time. No, I want to click on this and rotating it one more time clockwise. We get to the coolest things, all the fun stuff, the winter constellations, things that'll be way more easily visible in later than the evenings in this month. And in earlier in the evenings as we get, or sorry, later in the evenings and getting easier to see in the middle of the night and as the winter goes on. But this is really the great stuff. So here we've got what it looks like. We've got Orion here, and we've got Gemini. We've got Auriga, the charioteer. Down here, you're going to be starting to see Lupus and also Sirius, the dog star, and Canis Major, Canis Minor's down over here. And then over here, you got Taurus the bull. So let's see if we can see them in this without the sky map here. So first off, yeah, no duh, look, it's Orion, right there. There's Orion. Exactly, Krinkelschmidt got it. Orion, right there. And Orion is looking at, with the shield she's got right here, protecting her from the bull, Taurus. There's the V of the bull. And up above is in Taurus is the Pleiades. Pretty cool. The horns of the bull go up this way. And you can see if I turn this on, the horns going up. And then over here you've got the Charioteer, which is not an exciting constellation. And then down here you've got Gemini, Castor and Pollux right here. These two stars of Gemini, these two brothers that are very close. This is Aldebaran, and this group of stars that are not including Aldebaran, but the group of stars here are called the Hyades, and these are called the Pleiades, and they're two different, very young clusters of stars. We'll go back to Space Engine in just a second, right? But this is like your classic. Right now, if you are, I was out driving like last week, and right as sunset, you can see, as if you're driving east, you can see, look at how big Orion looks in the sky if you're driving. It's incredible. Can't miss it. Most people see Orion right now when it's this way because they very rarely look up. But this is a good time if you're out driving and being safe and socially distancing to try and look and see if you can see these sorts of things. This is the belt. Here's the shoulders, the legs. Here's her head. She's got this sword, this club above her head and a sword down here. And if you can see, it looks like there's 3 stars that form the sword, but actually this is the brightest part of the Great Orion Nebula, this incredible nebula that, if you could see it, stretches over almost all of Orion, the constellation, or at least the lower half. The Pleiades up here is a very young cluster that's surrounded by a reflection nebula of light reflecting off of gas in this nebula. It's a young stellar cluster. And this right here must be a Starlink satellite. It is lame that there are so many satellites because if you are observing in this part of the sky, they will just come right through your observation and there goes your observation. I'm not a fan. If we go on, make time go on a little bit more, so this is what it'll look like tonight at 10, 11 o'clock at night where I live. You see the winter hexagon. I showed you the summer triangle. Well, here's the winter hexagon. Are you ready? It looks kind of like, for those of you who enjoy video games, The Legends of Zelda. It looks like a rupee. We've got a star Capella down to Pollux, over here to Procyon, to Sirius, to Rigel, and up to Aldebaran, the winter hexagon. Pretty good. This in the center-ish is Betelgeuse. So down here is Sirius, the brightest star in the sky outside of the sun, the dog star, part of Canis Major. Canis Major is a really good constellation. It's the back of the dog's down here. This is the body of the dog. The head of the dog comes up here, and this is the front leg of the dog. This is Procyon, or Canis Minor, which is kind of like a little wiener dog. This is the body, and there's the head, little dachshund. We talked about Gemini, the brothers. I can turn the lines on. You can really see the brothers here. There's Canis Minor. There's Canis Major. Lepus, the rabbit that Orion is hunting, although she's fighting off this bull here. The bull Taurus, and Aldebaran's the eye of the bull. And then Auriga is the charioteer. And if I turn the art on, you can see it does not look like a charioteer at all. In fact, this art doesn't even look like a person with a charioteer. It looks like a person holding a goat and some sheep or whatever, like charioteer. Monoceros down here. I like Procyon quite a bit. Procyon, the word, means before the dog because it rises before the dog star does. Yeah, thanks, Elon. But this is our winter hexagon, and it's a really great thing to look for because it's all really bright stars across a big area of the sky. And so let's go back to our... and Crinkle, I hope you saw a bit of this, but please go outside tonight and look to see if you can see this incredible conjunction. Because if you look out right after sunset, you can see the sun is just set down here. It's only, I think according to this, it's, this is UT, but like it's right after sunset. If you look off right where the sun is set, the brightest thing you're going to see, there's going to be some other bright stuff, but they're not nearly going to be as bright as these two objects. And what you're seeing here, and again, I know maybe you're thinking, didn't you cover this for a half hour? I did, but I want to make sure to cover it for people who just joined us. Jupiter and Saturn looking like this in the sky. They're so close in the sky that to us they look like one object. They're actually really, really far away. But we looked at what this looked like earlier in this from Saturn, and it's a pretty cool thing to look at as well, especially because Jupiter is completely dark. It's the backside of Jupiter. So if we go back to here, let's look over in the other part of the sky. And I can see Aldebaran starting to rise. So if we let time go by a little bit faster, really get the stars coming out. Oh, there's Orion rising. So here we go. We were just talking about it, but there's Orion. And up there, you can see the V of Taurus the Bull, if I like make it a little easier for you to see. Yeah, this is like a really dark site right here. You can see Orion, you can see the Bull. So, the Great Conjunction, 6.3, hey, 6.3 arc seconds is nothing, you know, that's pretty incredible. This is the last conjunction, you know, like it's been 400 years since we've had a conjunction like this, so relish it. It's a good conjunction. Unless it's cloudy where you live, in which case just who cares. We can go fly, and you can see what Saturn looks like if we just take off towards Saturn. I like doing this. So if we click on this, I can really just see, because we're pretty far away. 705 parsecs. And now we're starting to fly towards the constellation. I can rotate a little bit so you can really see Orion. And as we get closer, notice, first off, the Hyades here, Aldebaran, we're actually passing, Aldebaran's way farther, and you can see this group of stars, the Hyades, right? And the Pleiades up there as well. You can see the Hyades is in fact a cluster of stars. This is the V of the bull's head, and there's the cluster of stars with its gas cloud around it. It's hard to see the gas cloud, but if I raise the, really get it, you can see the gas cloud starting to kind of be fuzzy around it. But that is the Pleiades. And if we go back and look at Orion, so we kind of fly back here. I think I've lost Orion. Oh no, there we go. This must be, yeah, right here. Betelgeuse, right? Yeah. So you're seeing that as I, you know, I've actually, there. There's a video game that I really liked growing up called Starship Titanic. And as part of it, you had to get back home by finding 3 stars and linking it. There was like a whole simulation of this in the game. That was like the final puzzle that was really tough. But you can see as we move towards it, these stars are just closer. There's Betelgeuse, enormous Betelgeuse. You know, the constellation, it just happens to be lined up. We love things that just happen to be lined up in the sky. And here are the 3 stars of the belt. Right? Pretty cool. Just happen to be lined up like that. We can kind of try and find our way back home. By those 3 stars. Pretty cool. Pretty dang cool. So this is the thing about the constellations. They just happen to look like that because of the way that we're just happening to look at them right now. And if you go to other planets in our solar system, they haven't changed at all. If we were to go to the moon here, that's Sirius. That's not the moon. Where's the moon? Is this the moon? That's Mars. Let's go to Mars. Here we are at Mars. Mars is a little low res right now because Space Engine has a hard time of rendering it. And we look over this direction. There's Orion. Same constellations. Not far enough away for things to change that much. Which is why it'd be kind of fun to live on Mars. Because, hey, all your star map books would work just as well. Except the times of the year and stuff because the way Mars goes around the sun. But that's pretty cool. So, it's like the last 10 minutes now. And if there are any questions, this is a good time to ask questions. But otherwise, that's what we can see right now. Here's Sirius, the brightest star in the sky. Let's go to Sirius right now. Sirius happens to be pretty close. It's not... Whoop. Here's Sirius. The thing about Sirius is 2 stars. My watch.
I'm always serious.
Thank you. I thought I asked, are you serious? Turns out I did not ask that. Sirius, from our perspective, looks like 1 star. But actually, we're just seeing this bright star. And then there's another star down here. So this is Sirius A, and here's Sirius B. Sirius is, in fact, a pretty bright star. But it's just also pretty close. It's a white main sequence star. It's an A-type star, so one of the brighter types of stars we can see. Oh, the planet's further out? Well, let's look at that. Once I look at it. So there's Sirius A, right? And if we fly away from Sirius A right now, you can see that it's orbiting what's called a barycenter, which is these two stars are orbiting, as they get around, they kind of whip around each other, but they're orbiting a common barycenter here. And if we look at Sirius B, it is a white dwarf. So it is a star that used to be alive, and its outer layers have puffed off, and now it is very, very, very hot and cooling down, but about the size of the Earth. This planet's about the size of the Earth and mostly made of carbon atoms. Pretty cool. So the question is, what about, let's go out to Pluto, dwarf planets. Here we go. We're going to get out there. Pluto right now is really dark because Space Engine's having a hard time of rendering it, but that's fine for our purposes. Sorry. You have to restart it. This is something that I wish I could make a bug report about it. Let's turn off here. Oh, the other reason is because I've got there. So here's Pluto. So the question is, are the constellations the same? Well, there's the sun. So we're in the middle of daytime on Pluto right now. I can see here the Pleiades. So I can see the V of the bull. And so where is Orion? Well, it looks like Orion's right straight ahead of us. If I turn, here's from Pluto what the constellations look like. Do you recognize anything? Oh, wait, what are you doing? It's wanting to land on the surface, and I don't want to do that. It turned me because I was on the surface, and it was craning its neck there. Same constellations. Turns out, even going all the way out to the edge of our solar system, not far enough away for the planet, the stars to move. Stars are really far away. Let's go to the nearest star. Let's go to the nearest star. Let's go to Proxima Centauri. Whoop, here we are. Let's look at its planets that it's got here. This kind of simulates the planets on this one. Proxima Centauri B. Boop. Again, Space Engine's not doing a great job of simulating it, but we're going to sit on here. So now we're at the closest star. So let's see if we can find where Betelgeuse is. Guess what? Closest star. Things are slightly different. Aldebaran has been moved a little bit. But still you see the V and you see Polaris. Things are slightly different right here. You've got Betelgeuse and you've got Sirius. Sirius has been moved a lot. Sirius is not, in fact, down in Canis Major anymore. Sirius has been moved up near the shoulder. So for the people living on the planets around Proxima Centauri, Alpha Centauri, or Proxima Centauri, if there are people or aliens, they would see the Orion having two shoulders here. But turns out not close enough. Or not, not far enough. Right? Pretty cool. Pretty dang cool. Where's the sun in this? Let's see what the sun looks like from this. There it is. So in their constellation, the sun is over here. Is this Cassiopeia? Yeah. The sun is like one of the other stars in Cassiopeia. Whoa, that's so neat. Because these must be the Cassiopeia stars. And then the sun. I wonder what they would call our sun. And then over here is Capella, the charioteer, which is, again, north in our skies. North, it's moved a little bit. The brighter the stars are, either they're inherently really bright and very, very far away, or they're just closer, in which case they'll move a lot more if you move around, right? Because you want to think about some stars that are really, really far away. You have to go really far to have them move a little bit. It's like saying, where do things look like when they move around my room versus, where does the city around me doesn't look like it moves much unless I get out of the city and then I can look at it and see that the buildings and things change a little bit. It is pretty neat. I think this is a very cool exploration. All right, so let's go back home. Fly back towards that star. And you can see that we're back here. And we'll land and finish where we started this whole fun thing. This is, the middle of the night. And we'll get back to our floating above the surface of the Earth here. Landward landed on it. And so your goal tonight is to go look at that conjunction, right? to make sure that you see that conjunction. All right, so let's make time go on a little bit faster. Where's the sun? There it is. As the sun sets, right after sunset, just look up and to the left a little bit from where the sun is set, and you'll see it right there. And I really urge you to go out and look at this because it's, you know, really, really beautiful. They're very, very close to each other. And you can see that it says their phase is here, 0.998 and 0.999. They're almost as bright and big because they're on the other side of the sun. You're seeing almost the entirety of the planet. They're just incredibly bright and beautiful right now. You know, really wonderful to see. All right, everybody, this was fun. I'm going to go drink some water and get ready to see this myself tonight. You all have a really wonderful rest of your evening. Let me know, you know. And remember, I should do this. This is my thing that I do at the end of this, which is I put on my Twitter and Instagram. Follow me on Twitter, follow me on Instagram, where I post about stuff like this. Click like and subscribe for when I post more videos. It's going to be a little bit, my neck seizes up when I do this for long enough because of the whole breaking my shoulder thing. But I'm doing all right. And I really appreciate you watching. Have a nice rest of your day. Bye, everybody. I have to wait until YouTube does that, or else I'd lose the last one under my. It doesn't matter. So if you're watching me now, cool. That's great. This is a fun time. Watching it right now, it looks like I haven't actually gotten to this part yet.